Humanoid robots are not taking over the world in the movie sense. They are beginning to take over the work that automation left behind, lifting totes, moving parts, feeding production lines, inspecting components, loading fixtures, and walking through facilities built for people. Traditional robots won by making dedicated production lines incredibly fast. Humanoids could matter for the opposite reason. They may bring automation into old factories without rebuilding everything around a fixed machine. That is why robots shaped like us are suddenly an industrial priority. The real race is not to create a mechanical person. It is to create flexible robot labor and to learn how to deploy it safely, cheaply, and repeatedly before competitors do. 4 forces arrive together. First, physical AI, vision language action models, reinforcement learning, teleoperation, simulation, and world models. Let robots learn from examples instead of having every motion programmed by hand. New 2026 work from Huawei-linked researchers, Tencent Robotics X, and open embodied model teams is pushing planning, spatial reasoning, feedback, and self-correction. Second, hardware is moving down the cost curve. Actuators, batteries, cameras, force sensors, edge chips, and motor controllers are improving together. Third, aging populations. Labor shortages, reshoring, and reluctance to perform repetitive physical work are increasing demand. And fourth, the world already fits the human body. Doors, tools, shelves, trolleys, stairs, and workstations were designed around us. The International Federation of Robotics counted 542,000 industrial robot installations in 2024, more than double the number 10 years earlier. Asia captured 74% of new deployments, and China alone accounted for 54%. Humanoids are arriving on top of an automation wave that is already enormous. The strongest examples are boring, and that is the point. BMW says Figure 02 supported production of more than 30,000 WEGS 3 vehicles during a 10-month deployment at its Spartanburg plant. Working 10-hour shifts 5 days a week, it retrieved and positioned more than 90,000 sheet metal components for welding and accumulated roughly 1,250 operating hours. In logistics, Agility Robotics says Digit has moved more than 100,000 totes in commercial deployment at GXO's Georgia facility. Digit links mobile robots with conveyors inside an existing warehouse instead of demanding a new building. Mercedes-Benz is training Apptronic's Apollo to transport parts, deliver assembly kits, and perform initial quality checks, using teleoperation to transfer workers' knowledge into the system. Europe is now planning larger scale. A May 2026 agreement calls for British company Humanoid to place roughly 1,000 to 2,000 robots across Schaeffler's global factories by 2032, beginning with German deployments from late 2026. That last case is a plan, not an accomplished rollout. Together, the examples reveal the first market, repetitive material movement inside brownfield factories and warehouses. China enters this race with a structural advantage. It already operates the world's largest stock of industrial robots, has dense electric vehicle and electronic supply chains, and can source batteries, motors, sensors, reducers, and control electronics at scale. Merix estimates that China produced about 12,800 humanoids in 2025, roughly 90% of global output, although many went to research, training sensors, and limited industrial trials rather than autonomous full-shift work. The same report warns that Chinese humanoids still lack precision and dexterity, and may perform some factory tasks at only about half human efficiency. That caveat matters. China is ahead in volume, not finished capability. Its strategy appears to be, make robots cheaper, deploy them earlier, tolerate imperfect performance, collect real-world data, and improve through repetition. Yubatech has trained Walker robots at BYD, Geely, Foxconn, and other plants. Agibot robots have completed reported electronics line shifts. Robotera machines have entered logistics centers. China's 2026 national initiative now targets more than 100 high-value scenarios and deployment capacity at the 10,000 unit level. China is not ahead in every layer. The United States remains strongest in frontier AI, Chips, cloud infrastructure, venture capital, and high-profile platforms from Tesla, Figure, Agility, Apptronic, and Boston Dynamics under Hyundai ownership. Its risk is mistaking demonstrations and fundraising for reliable mass deployment. South Korea combines Hyundai, Samsung, LG, dense manufacturing, and deep actuator and electronics expertise. A June 2026 Goldman Sachs forecast says Korean companies could directly or indirectly support 30% of global humanoid production by 2035. Japan retains formidable industrial robot and precision component companies, but has commercialized humanoids more cautiously. Europe has world-class factories, machinery, safety expertise, and suppliers such as Schaeffler. Its danger is becoming the buyer and component maker, while someone else owns the robot platform, software, and data. Leadership depends on the layer being measured, but China is currently connecting more layers through manufacturing scale and fast deployment. The maximum advantage does not come from buying the first robot. It comes from building the first learning system around it. Early adopters collect task data. Failed grasps, awkward bin positions, glare, tool misalignment, people entering the work cell, and floors that are never perfectly flat. They learn which processes need redesign and where humans should remain in the loop. They connect robots to warehouse and manufacturing software, safety systems, line control, charging, maintenance, spare parts, and shift planning. They influence hands, payload, batteries, APIs, service contracts, and safety features. And they train technicians, robot supervisors, process engineers, and AI maintenance teams before those skills become scarce. This is the compounding loop. More robots create more data improves models, better models increase uptime, higher uptime improves economics, and better economics justify more deployments. The winner will not simply own the best machine, it will own the fastest learning loop. The first industrial revolution mechanized muscle. The second scaled electricity and mass production. The third brought electronics, CNC machines, programmable controllers, and industrial robots. The fourth connected factories through sensors, software, cloud systems, and data. The next phase brings AI off the screen and onto the factory floor. Traditional industrial robots remain unbeatable when the task, part, and environment never change. Humanoids become interesting when tasks change. The building is old, custom redesign is too expensive, or labor is difficult to recruit. The first wave is warehouses, automotive plants, line-side logistics, inspection, kitting, and repetitive handling. Retail and healthcare support may follow. Construction, agriculture, clean rooms, and homes are larger possibilities, but much harder environments. The blockers are less cinematic than the demonstrations. Reliability means thousands of hours, not 5 impressive minutes. Dexterous hands still struggle with soft, tangled, tiny, slippery, or deformable objects. A walking machine near people creates safety questions around falls, pinching, unexpected motion, cyber attacks, emergency stops, and liability. Batteries must fit real shifts. Joints, sensors, covers, grippers, and actuators wear out. Maintenance and supervision can destroy the economics. Ultimately, companies will compare the full cost per completed task, not the purchase price, with human labor, downtime, service, charging, integration, and failure recovery included. There is also labor politics. Deployment without retraining, worker participation, or a credible transition plan can create resistance. The winning model is unlikely to be humans or robots. It is a process that assigns repetition and physical strain to machines while moving people toward judgment, supervision, maintenance, and exception handling. Forecasts reveal how uncertain the timing remains. Goldman Sachs has projected a $38 billion humanoid market by 2035. Morgan Stanley describes a possible $5 trillion ecosystem and more than 1 billion humanoids by 2050, while also expecting adoption to remain relatively slow until the mid-2030s. Those estimates use different horizons and assumptions. They are scenarios, not promises. For industrial planning, the nearer-term question is simpler. Can a robot complete a useful task reliably at a competitive, all-in-hourly cost? Humanoid robots are not yet everywhere, but the industrial race has already started. The first winners will begin with narrow, boring work, build deployment knowledge, collect task data, train their workforce, and redesign factories around human-robot collaboration. China may win hardware scale, The United States may lead frontier intelligence and platforms. Korea and Japan may dominate critical components. Europe may lead safe industrial integration if it moves quickly enough. The danger is not that humanoids replace everyone tomorrow. The danger, for companies and countries, is arriving late to the learning curve.